In this example, we're given two similar pyramids. I don't need to prove they're similar. The problem tells me that they are. And so what I'm going to do is I'm going to make a chart to organize the different ratios, as we did if you watched the previous video. So the first thing I'll need to do then is figure out what I know about both pyramids, whether it's a side length, a perimeter, a surface area, or volume. There's something I should know about both of them. And reading the problem, I can see that I have given to me volumes of both of the pyramids, the big one and the small one. And so I'm going to use that to begin my chart. Now, since those are volumes, of course, I'll begin in the volume column. And this problem tells me to go in a specific order, pyramid P, the larger one, to pyramid Q, the smaller one. If they don't tell you what order to go in, you can use any order, but if they do tell you, make sure you go in that order. So my volume ratio is then going to be 1,000 to 216. And so I'm going to use that to kind of work backwards and find the different other ratios in my chart. Well, before I do that, though, it's very important to simplify first. It's an easy thing to forget about, especially something like this, where if I were to work backwards, which I will in a moment, to work backwards from volume, we're going to take a cube root to do that. The numbers they gave me are perfect cubes, so I may not recognize that I should simplify. Sometimes the numbers are irrational and we get decimals, and so we would know maybe to try to simplify first, although sometimes they are just going to be decimals. Anyway, all this is to say, let's simplify first. I know that 1,000 over 216 can be simplified because both numbers are even. Using a calculator, I can simplify that down to 125 over 27. So that's the ratio I want to work backwards from. Since that's volume, as we said, we're going to work backwards by taking a cube root. The cube root of 125 is 5, and the cube root of 27 is 3. So my scale factor, the ratio between the sides of these two pyramids, are 5/3. The perimeter ratio is the same thing as the scale factor, so that's also going to be 5/3. And then to find area, we're going to square each of those numbers. 5 squared is 25. And 3 squared is 9. So there's the chart filled out. Even before I read whatever the question was, that's the chart filled out. So let's go back and see what the question was. They asked me to find the scale factor of P to Q. Well, guess what? We already did that. In our chart, we know the scale factor between the two pyramids is going to be 5 to 3. The ratio between their sides is 5/3. The question down here said find the ratio of the surface area. Well, turns out that the ratio of the surface areas, it doesn't matter if it's area or surface area, it's the same thing. So the ratio of the surface areas of the two pyramids is 25 to 9. So there's the two ratios I need. That's all they ask me for. They don't ask me to find any other volumes or surface areas. So that's not a lot of fun. Let's do a similar problem, get it, similar, where we do have to find the volumes and surface areas. So again, we're given two similar figures. We know they're similar. They've told us they're similar. We don't see one of them. We see one figure, that's solid A. We don't see the other one, but that's okay. In fact, we don't even really need to see either one if we use this chart. So that's how I'm going to begin. Nothing in the problem tells me to use the chart. However, I always start these problems with this surface area or scale factor, perimeter, area, volume chart. So there's something I should know about both pyramids. In this case, they tell me straight out what the scale factor is. So I'm going to start with my chart. Start my chart with that. 3 to 1 is my scale factor. I know the perimeter ratio is the same thing as the scale factor, so that's also 3 to 1. To find the ratio of your areas, whether it's area or surface area, same thing. I'm going to square each of those numbers. So squaring those gets me 9 over 1. And then to find the ratio of their volumes, I'm going to cube each of those numbers, raise them to the third power. So 3 to the third is 27, and 1 to the third is still 1. So there's my chart filled out. That was really important to do because to answer the next part of this question, or to really answer the question, I need to find the volume and the surface area of the figure I don't see. And so I'm going to draw a line between here to separate these two parts of the problem because this confuses a little bit. Confuses people the way they set it up. The S stands for surface area, just to clarify that. So I'm going to just mention that real quick. So S is the surface area of the figure that I see, and then V is, of course, the volume down here. So it's really two problems sort of in one. Let's start with the surface area. To do this, I'm going to write a proportion. I'm free to use any of these 4 ratios to start my proportion. However, I have to make sure I choose the appropriate one. Since I'm dealing with surface area, I need to make sure that I choose the area ratio. It seems like kind of a no-duh thing, but I'm always surprised at how many people I see pick the wrong ratio to use or not think about it. Since it's surface area, I'm going to use the surface area ratio. Then let's see, to do my proportion, they've given me 1,500 as the figure that I see, so that figure goes on top. over the surface area of the figure that I don't see. That's the one that's on the bottom then. So I'm going to use an S to represent that surface area. So there's the proportion. Let's go ahead and do some cross multiplying to solve that. So 9 times S is equal to 1500. If I divide both sides by 9, I get a surface area of the smaller figure of 166.6 repeating. Now I'll include a label since they gave me a label. That's going to be meters squared. Okay, so there's the surface area, and again I chose to use the area ratio from the chart. So next up, they also asked me to find the volume of this figure. So let's go ahead and do the second part of this problem and find the volume. Once again, I'm free to use any one of these 4 ratios from the chart. However, I have to make sure I choose the right one, and since I'm dealing with volume, not surprisingly, I'm going to choose the volume ratio to use for this. So I'm going to set this up as 27 over 1. Equals, I know the volume of the figure they gave me, what a weird number, but they gave me 3434.6. That's the figure I see, and that's what I've been putting on top, so I'll be consistent, over the volume of the smaller figure. So let's again cross multiply and get 27V equals 3434.6. And finally, dividing both sides by 27, I get a volume of the smaller figure to be about 127.21, and again I'll include the label that they gave me in the problem, meters cubed.